Good morning, one and all. I hope you're all doing well. Now, this is Dr. Diana here. We started with data mining and we understood what data is, how data can be converted into information using statistics. And then we also saw that data mining algorithms can help transform that information into knowledge. Knowledge in general is represented in the form of patterns, and these patterns can help us understand the past behavior of a system, and it can help us predict the future behavior too. Once we understand the feature behavior of a organization or of an object of a person or a group of persons, it helps us in business decision making. So the entire objective of data mining is to help in business decision making based on some of the previously available data with us. And we have seen an introduction to what data mining is, and we have seen the formal definition of data mining, and we have also looked into the knowledge, KDD process. KDD is nothing but knowledge discovery from databases or knowledge discovery in databases. So this knowledge discovery is data mining in other alternative words. Now this data mining, it fits as a part of this KDD process. So it's only a part of the entire stream of KDD process. And we have seen what are the levels in data KDD process. The first one starts with data cleaning, and then with data integration, and then into selection of data towards task relevant, application specific or goal centric analysis, and then we do the data mining on the selected data. Then you evolve patterns from that. This pattern is evaluated based on the interestingness of the pattern. The four different parameters used to assess the interestingness of the pattern are how non-trivial it is, how implicit the pattern is, how previously unknown the pattern is, and also how potentially useful the pattern will be in taking business decisions. So based on these parameters, we evaluate the interestingness of a pattern, and then we obtain whatever knowledge we consider as interesting, we put it inside the knowledge base of the organization. And we've seen some of the different types of data mining tasks. We've seen 6 different data mining tasks. Those are generalization, association rule mining or correlation analysis, and then we moved on into classification, clustering, time series analysis, and network analysis, outlier analysis. So all of these we have seen as different data mining tasks. Now we are going to move on into data pre-processing. Now before we even start with our data mining task, the data has to be cleansed and should be appropriately selected for analysis. I'll tell you an example of how this process works. Now imagine the DMart store. We'll be continuously talking about the DMart store because our idea of using data mining is for a business enterprise and for making decisions. So if we can relate it with a practical example whenever possible, it will help you understand the subject better. So I'll be taking up the DMart point of sales software and the data associated with it, so that it will be easier for you to correlate with. Now imagine DMart is available. So they have a store at Kompally, they have one at Sanat Nagar, they have one at Miapur and everywhere. And each of these DMarts have different products available. And each center there, they have 90 percentage of the time the same items available. But there are few other items which are available uniquely to certain stores. That is based on the movement of the product, they actually buy and store on those products. Now, and each store gives certain different types of discounts and offers. Imagine there is some item that is overstocked at Kompally and they are not able to sell it out. They release it during some discount and then give it as a Diwali discount offer price, this, that, and everything. This same offer may not be available at DMart Miapur, right? So each of these, even they use the same POS software. POS means point of sales software. So even though they use the same POS software, their sales, their offers, their strategies of sales are going to be different from each other. So when I say a product was billed at 100 rupees at DMart Kompally during the offer, might be costing 150 rupees at DMart Miapur. So each item can carry a different sales price at different places. If that is the case, when I try to integrate all of this data, I cannot use the same table structure. The table structure in DMart Kompally will have cost price, selling price, etc., offer, etc. The same data, if I try to merge with data from DMart Miapur, I may not be able to do it that easily. So in that case, this is a very simple example that I have taken. Now imagine organizations that work across the world. There's a Walmart store in US, one Walmart store in UK, and then there's one at Singapore. The products are going to be different, the prices are going to be different, the offers are going to be absolutely different. So when I try to form some strategic business plan for Walmart, the data that I look in is from multiple heterogeneous sources and I'm not able to integrate them. So if I want to take some decision out of this data that I have, I need to pre-process it. I need to put them into some form or integrate it into some homogeneous form or one singular integrated structure and then apply data mining upon that particular data structure. So that's our intention in data pre-processing. So the second half of unit 1 deals with a lot of pre-processing methods. So they start with data cleaning, missing data, dimensionality reduction, feature selection, discretization, transformation, and measures of similarity and dissimilarity. All of these are going to be used for some way of pre-processing of the data. The first thing we will start with is an overview. Why should we pre-process the data? When we say we want to pre-process data, we are saying that we want quality in the data that I want to mine. So there are certain measures used for quantifying the quality of data. The first one is the data should be accurate. It should be correct and not wrong. I should be able to see whether the data is accurate or not. And then if the data is not accurate, I should be able to do something to correct that aspect. Right? And completeness of the data. This is a major problem when we talk about attendance data. Most of the things are incomplete. One faculty did not enter the attendance for one particular fortnight. One student did not turn up. We are not able to decide, and he has given a medical certificate. We are not able to decide what to do. And there is information passed over to the parent. The student's phone number, the parent phone number is not available. So these are aspects where the data becomes incomplete. When the data is incomplete, analysis of that data will also result in incompleteness. The pattern that I mine using data mining may not be complete either. It may not be applicable to most of the other data objects. So that will become difficult if we start working things like that. The second thing is consistency. Consistency is a heavy duty issue. In one of the student records, the parent's phone number is given so and so. In another student record, it is a different number. And when I ask the student personally, he gives me another number. Where is the consistency in all of this? How do I materialize? So that is called inconsistency in data. It is wrongly given in different places, and data in one table does not reflect the same thing in another table. So that becomes heavy. And the next aspect is timeliness of the data. Now you can say, I have been uploading fortnight attendance. Fifth fortnight is complete. I should be submitting the fifth fortnight attendance. Instead, I am submitting the fourth fortnight attendance. How timely is my work? If I entered the data from a different time zone, is the data still accurate? Is the data still correct? It is not correct. So to avoid incorrectness in data, data must be updated in regular periods of time. And the other option is really shocking, but your textbook says believability is a real issue in data mining. Why do we have this question of believability? Imagine a student has got 100% attendance in final year 4-2. The moment you look at that number, will you think that the data is correct, or will you think that somebody entered the wrong data? So that is called as believability. So the data, when it is entered wrongly, you can easily spot it out because you are unable to believe it. That is one aspect of identifying incorrectness in data. So once you identify that, you can take measures to correct that. The last parameter of data quality is interpretability. How easily am I able to understand that data? Unless the data is interpretable when it is given for input as input to mining, the output that I receive after using that data cannot be understandable. So imagine to represent attendance of a student, I use a numeric data type, or some say for example I use a character data type for representing attendance. So the character data type I use, the first fortnight attendance is 15 classes. Then the second fortnight attendance is 20 classes. So in the field, in the database, I enter it as 15-20-23, etc., where each of the numbers separated by hyphen represents the corresponding fortnight's attendance. If I represent the data that way, it is very, very hard to interpret what that data means unless I tell you, or the database administrator tells you what the data means. It is difficult to understand what it implies. Now, if I give such a data to the data mining algorithm, the result or the pattern that I attain from using data mining also will be ununderstandable, and it may not make sense at a later point of time. So the data which we have should be interpretable. So these are the qualities in data which are to be maintained before we even start applying data mining algorithm. The first one is accuracy, completeness, and then consistency, timeliness, believability, and interpretability. So these aspects we should check for in the data that we provide as input for the data mining algorithms. Now, these are some of the data pre-processing tasks. The first one is data cleaning. Data cleaning, we'll be looking at each of these in depth in the next few sessions. The first one is data cleaning. The second one is data integration. The next one is called data transformation and data discretization. In the previous curriculum, data integration was added in the curriculum. In your syllabus, data integration is not available because it is altogether a different concept. It's how warehouses are designed, architecture of the warehouse, how do we develop a warehouse, and all of that comes under data integration. Because data warehousing has been removed from your syllabus, they have removed this data integration also. But it is good to know what data integration is and what are the challenges we come up in data integration. The other three aspects are dealt with in detail: data cleaning, data reduction, and data transformation and discretization are the what we will discuss in the rest of the first unit. Now, we will directly move into data cleaning. When I say cleaning, what does it mean? What is the little meaning of the word cleaning? It's so difficult for us virtually. Without people who can interact, the class becomes so boring, right? I feel like that. When people, I'm not able to see your faces, and when I'm not able to hear your noise, it is quite difficult for us to take class. Okay. Now, what is data cleaning, or what is cleaning in literal sense? Cleaning is to remove the dirt. Okay, and cleaning means ordering of something. Okay, organization of something. Okay, essentially it means to remove some uncleanliness. Right. Now, what is uncleanliness in data? Tell me, what is uncleanliness in data? How do I define uncleanliness in data? When do I say that the data is not clean? Imagine you look into a Facebook profile. The person has put off some beautiful rose picture in their DP, and they've given some information about them, and nothing seems to be personal, or they have not revealed their personal information there. In that case, can you call the data as clean? No. Why? Because it is not true. Okay. And in some of the tables, you are given your syllabus, and in the syllabus, imagine under unit 1 there is nothing. Right from unit 2, some of the content has been given. There is no information on the textbook or the reference book. Will you say the data is clean? No, it is incomplete. Then, when you look into the syllabus, they have actually, in the previous syllabus copy, there was some mistyping. Decision trees is a topic, but in the syllabus book, it was printed as difficult trees. Can you say the data is clean? No. It means there is some error in the data. So these are forms of uncleanliness in data. Either the data is not true, or the data is incomplete, or the data has been wrongly entered with an error. So all of these are forms of uncleanliness in data. In real world, the data is actually very dirty, or I can say there is lots of potentially incorrect data. Example, when I tried, when I was typing in some web form which was collecting my information, I lost internet connectivity. So there was a fault in my instrument and it didn't enter the data properly. And then you have human or computer error. Imagine I tried typing in Word and I uploaded it as a Unicode text file. The internal Unicode format has changed and I am not able to read it properly. I uploaded a PDF image I tried to open it at JPEG. The file got corrupted. So these are some of the ways in which uncleanliness is introduced in the data. Upon all this, we can see that data is continuously being transmitted from me to a web server, from a web server to another person. So it keeps on transmitting. And there are a lot of transmission errors that occur. So every time some of these things happen, there is some degree of uncleanliness that is introduced in the data. Now, when I sweep the floor, it is also cleaning. Only when I see when there's dirt and I try to remove it, I can call it as cleaning. So in the same way, when I try to clean data, I should first be able to identify the dirt. Only then I'll be able to clean. Right? So these are some of the aspects of uncleanliness in data or the dirt in data. The first one is a incomplete data. So you have a table where you have some value that is missing. Most of our tables in student data collection, we can see that the occupation of the father and mother is missing and it has not been entered by the student. And the best thing is they never enter the communication details of the parents. So that's incomplete data. The second one is noisy data. What is noise? So noise is an error. Here the example given here is salary, which is minus 10. Salary can never be minus 10. At least it should be 0, even if they are not giving us salaries. So it's either 0 or some positive value. It cannot be negative. And age cannot be negative. And that is called as noisy data. So, and outliers are exceptional and very rare kind of data. Imagine some student has completed degree and after completing degree they wanted to do some BTech and they came and joined. Their age is alone 24 in the first year. That is an outlier or it is a very rare and unusual case of data. So when you look into the database, the age of all students is 18, 19 and odd, and there is one student whose age is 25. So that's a noisy data. And then you have inconsistent data. Inconsistent data is where data is represented in one table in a different form and it is not complying with the same data in another table. Imagine I have given my birthday as so and so in a particular table, and in the same table I have given my age as 45. Okay, and next year when I look into the same data, my date of birth is going to remain the same, but my age was not updated. It was updated by the time they entered. When I turned 50 also, it will still show it as 45 only. So that becomes an inconsistency. It does not convey the same meaning as the date of birth information which is held by my same table. So this inconsistency should be sorted out. And the last one is intentionally wrong. Our students are wonderful at entering intentionally wrong data. Whenever a parent's mobile number or communication number is asked, they give their friend's number, and once we fools like mentors, we call parents, no, then we understand it was not the parent's number. So those are intentionally wrongly entered data. That is also error. Now these are forms in which dirt exists in data. Now I should find out methods for correcting or cleaning each of these types of uncleanliness in data. The first thing we will talk about is incompleteness in data. Data or missing data, I can say. Why, if we understand why that data, dirtiness or the dirt occurs in data, why data becomes incomplete, it is easier for us to fill or correct that incompleteness. The first reason for incompleteness in data is data might not be available at that point of time. Now imagine I started entering a student's information, and from all the certificate copies that I have put his SSA hall ticket number and his aggregate marks. But the student did not submit a copy of the Aadhaar to me when I was entering the student data in the system. So the Aadhaar number field was not entered. I asked the student to come back with the Aadhaar copy, but he has not submitted to me yet. So I forgot after that to follow up. So that becomes an incomplete field. So when the data is being framed for the first time, if data is not available in hand at that point of time, it may become a missing data. I might forget to update that data later. And there are instances when the data was not recorded at all. I was asked to submit the student information to AACT by the end of the academic year. By the starting of the academic year, I have not collected that data from the student. So when I upload, I didn't have value for that. And data may be missing due to other reasons also. Equipment malfunction, inconsistent with other data records, and so it was deleted. Say for example, I have a student's mobile number. In one of the form it is a number, in another form it was a different number, in another form it was still another number. So what I did was, instead of looking into that data, I just deleted that phone number at all. So that is deleted because it was inconsistent with other records. And data was not entered due to some misunderstanding. Some handwritten number was given to me. I didn't understand that value, so I did not record it properly. So that also accounts to inconsistency in data. And then certain data may not be considered as important at the time of entry, but later at some point of time I might realize that the data is very important and I might need them back. So in that case, I'll have to still call for another submission of data. Only then I'll get the data back. And it was not registered in the history or changes in the data. So I have been making changes in data. I got one phone number from a student. I entered it. Then I found that the student's phone number has changed, was not reachable on that number. So I took another number. So what I did was I replaced the previous number with the new number. In that case, the previous number is lost forever. So the history is not maintained properly. In that case also, we might end up missing some data. Data may need to be inferred, which means, say for example, date of birth is available. I can find out the age. It can be inferred from some other data sources, but for now it is not complete or it is missing. How do we handle missing data? Before data mining, we need to give complete data for the data mining algorithms, otherwise we will not get the right kind of knowledge. So in that case, if out of 150 students, one student's data is missing, so what they usually do is they remove that entire details about that particular student and then give that data to the data mining algorithm. That is called ignoring the tuple. When you ignore the tuple, that is not considered for analysis under the data mining task. And then you can fill the missing value manually. Imagine the age column is missing, but the date of birth is available. You can find out and manually fill, but it is very tedious and it is very infeasible also. Imagine if I have got 500 students, I might try to do it. If I have got 10,000 students, how do I do it? Not possible. So it might be impossible when to do manually. So what are the other methods we can use to automatically fill that missing data? One is a global constant. So if I can say he is a 17 BK student, enter the age is 20. I can give it off right away. So that is one form. I can give a constant value and update that entire column using the same constant value. Wherever it is missing, you put the same constant value. and or I can take the mean of that particular attribute. In when I say a global constant, I have to define a constant for 17 BK students, to define a different constant for 18 BK students. So it becomes difficult. So in that case, what they usually do is you find out the average age of that particular column and then update that missing value. Imagine all from his class has got 20, 21, 20, 21. Then update it as 21 or 20. So that is how we update it using the attribute mean. And attribute mean, when I say attribute mean, I have the data of 17 BK students, 18 BK students and 19 BK students put together. And the attribute mean takes mean of all ages of second year, third year and final year students, which might be wrong. So in that case, the last but one idea says that the attribute mean for all samples belonging to the same class. So I find out the class, all the 17 BK belongs to one class, all the 18 BK belongs to another class. So for that particular class, I take the attribute mean and then update that value accordingly. So that it makes sense, right? uh, these are all simple statistical methods, but if you want to get very precise values for that missing data, you might have to use an inference based Bayesian formula. So a Bayesian network can be used to generate what the age would be. So it is guessing of the most probable value for that particular column. So this takes time. So you need to train a system that can find out this value for you. But we will be dealing with Bayesian networks later in our sessions. So at that time when we talk about this, you will have a better clarity on why we use Bayesian methods for finding out the perfect value or the most probable value there. And the second form of dirt is noise in the data, or it is a random error in the variable. How do I correct noisy data? Incorrect values may be due to faulty data collection instruments. So if I'm recording ECG and that has a lot of up and down values, it is noisy data. In medical field, noise in data is very, 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 very important. If your system is becoming insensitive to noise, then you will end up identifying or costing lives. So removing noise is a very, very essential part in data analysis. And there may be problems in data entry. So I have a keyboard problem. So I try to press the key 8 and it didn't work properly. I wanted to press 89, but because 8 was not pressing properly, I clicked on 9 alone. So it became a single digit, and instead of 89 marks, it became 9 marks. That's a data entry problem. And then you have transmission problems that occurs all the time. And we have a technology limitation, which means I can't store more than 0.6 point precision in some of the machines. And inconsistency in naming convention. This is a very hectic problem because I store one some place as for a student information. I store the student name as name. In another file, I store the student name as name of the student. In another, I say full name of the student. So when I try merging this data, everything becomes noise. So it becomes inconsistent with what I have been trying to merge. And apart from these, there are problems where you have duplicate data. I try to merge from multiple files, and 10 student information from this is also present in that particular class. So when I merge, I get 10, the same is repeated twice. So when data mining tries to apply, it will say those 10 people seem to be very important in the class pattern that is evaluated. So that's very difficult. And then you have incomplete and inconsistent data as usual. Now, how do we handle noisy data? When we handle noisy data, the usual method that's used is the binning method. Binning method means, I'll tell you an example of noise. Student marks has been entered. The student has got 70 percentage marks in 5 subjects. The sixth subject, there was some problem in the entry, and it was 70. The actual mark was 76, but due to entry problem, it was entered as 7. Okay, and so what happens is the rest of the 5 data samples for the particular student denotes 70 odd, and this one shows that the mark is 7. When we try to find out the average, it may not work because the student might have got 70 in one, he might have got 85 in another. So finding out average will not solve this problem. So what they usually do is they do something called as a binning. Binning is where you sort out the data. So you have the entire class data with you. One student's mark is what you are unable to find. So you sort the entire class data and you partition them in according to marks. So they, according to the data mining subject marks, you partition them. And then you find out a value from that particular bin. Imagine I have sorted out the data of all the marks of the class based on the data mining marks. I can see that I can divide the data into bins. Bins means I have 5 samples that have marks from 50 to 60. I have 5 students whose mark is from 60 to 70. Like that, I divide it into bins, and I look at the value of other marks of the students belonging to the same bin. Okay, now imagine a student has got 50 marks in data mining, and I have 10 other students who belong to the same bin who have got 50 odd marks in data mining. Then I analyze the rest of the marks for that particular group of students. In that case, I group them into a bin and I finally smooth out on some arithmetic mean value based on the entire bin data. So this will be used for handling noise in the data. Then you use a next category called as regression. Regression in simple terms is only line fitting or curve fitting. So I plot all the values and then say, then draw a line on it, it becomes regression. So imagine a person's salary is not mentioned, or it has been mentioned as 5 lakhs per annum, and I feel that it is wrong. In that case, what happens is I plot the age versus salary for all the other samples in that particular data set. So I have the age as 5 and the salary is 10, age as 20 and the salary is 20,000 per month. Age as 21 and it has raised to 30,000 per month. So I plot it accordingly and then draw a line or a curve. This line will give me the result when the age was 35. So you can just extend your line and find out what will be the salary of that person at age 35. And if you have in your data set a person with age 35 and there is noise in his salary in data that is entered, you can use the regression line to find out or estimate what will be the most probable value and then use that into your data sources. Then you can also use clustering. Clustering is very similar to binning, but instead of sorting that data based on the value that I need, I try to group the people in the class into different groups of who have similar learning behavior, and then according to that I can find the marks. So I'm not, instead of sorting, if I do, it's called as clustering. And then you can always use combined human inspection also. So I use any of the above methods to find out a probable value, and I might feel with my intuition that it might be somewhere close to that value. I can adjust